Okay, we're going to take a look at section 5.1. It's polynomial functions and adding and subtracting polynomials. This is Ms. Ron. I decided that I wanted to give you some videos in my own voice and add a little to the lectures as they were. So let's try this for this week. First, let's look at some terms, some definitions. A term is a number or a product, meaning a multiplication, of a number and one or more variables raised to a power. Now remember, it's either a number or a product of a number and a variable. So if we look at negative 10x to the fifth, that's a number multiplied by a variable. That's a term. X squared y, that's one term because it's a product of variables. Negative x, that's a variable. 2, that's a number. 5x squared y cubed, that is a product of numbers and variables. Now suppose I came over and I put 5x plus 3y. Now, this is a term and this is a term. So if you'll notice, if there is a plus or minus sign between these, then you now have multiple terms. So a term is a number or a number multiplied by a variable. We talk about a numerical coefficient of a term. That's actually the number sitting in front of the variable. So if we have negative 10x to the fifth, the coefficient is the negative 10. If we have x squared y, well, the coefficient is 1 because there's an understood 1 sitting there that we don't ever write. 5x squared y cubed, the numerical coefficient is the number 5, coefficient. There's another term called a constant. It says if a term contains only a number, then that is a constant. For example, the number 5, the number 2, 19, that would be a constant. Okay, let's look at the second page, and now where you can read it. A polynomial is a finite sum of terms in which all variables are raised to non-negative integer powers and no variables appear in the denominator. Okay, now let's look at this. This is where we're going to put several terms together. A polynomial. Poly means many. If we have 4x to the fifth y plus, notice they're added, 7xz, that's a polynomial. There's one term, there's two terms. Negative 5x cubed plus 2x plus 2/3, there's a polynomial, 3 terms. Now notice this has a fraction, but if you'll remember, it said that, didn't say anything about not having fractions. It said not having non-negative integer powers and no variables in the denominator. And if you look at this denominator, there's no variable. What are not polynomials? Well, look at this one. What would make that not a polynomial? The non-negative integer power. You see the negative 3 power? That makes it not a polynomial. 6 over x squared. No variables in the denominator. So that's not a polynomial. Now, to be very honest with you, we're going to be working with polynomials. So we're not going to be working so much with these that are not. You're going to hear some terms over and over and over, and you've already heard them. A polynomial is written in descending order. Now, when we mean that, we mean according to a variable, you're going to go from the highest power down, from the cubed term to the squared term to the constant term. Now, if you have a monomial, it is a polynomial, but it's one term. For example, 2x. A binomial is a polynomial of 2 terms. Well, that might be x plus 4. 2 terms. A trinomial is a polynomial of 3 terms. What about x squared plus 3x minus 1? We use 1 term, 2 terms, and 3 times so many times that we just give them special names. Mono, bi, and tri. Anything. Now, these are all polynomials, but anything over 3 terms, we talk about it as a polynomial. Okay, a few more words, terms. Each term of a polynomial has a degree. Now, what is the degree of a term? Now, remember, a term is one grouping of a number multiplied by a letter, possibly. The degree of a term is the sum of the exponents of the variables. All right, here we go. The degree of a term now, one term, 3x to the 4th, is the degree 4. Here is a multiplication of constants and variables, negative 2x cubed y to the 5th. Now remember, it's the sum of all the exponents. So we have a 3, we have a 5, 3 plus 5 is 8. Now remember, it's the sum of the exponents of the variables. So 8. All right, if you just have a y, what is the degree? Well, it's understood to be y to the first, so it's a 1. Okay? All right. Here we have 12x squared yz cubed. Well, the x has a 2 exponent, the y has a 1 exponent, the z has a 3 exponent, so that's going to be a degree of 6. All right, let's say we have 5. Well, now 5 is a constant, and remember the degree comes from the exponent of a variable. So if we wanted to do this, this is actually 5x to the 0, and it goes back to the old thing that anything raised to the 0 is actually 1. So this is actually a 1. So the degree is actually 0. So the degree of just a constant term is 0. One more thing I want to go over here. What if I had 4 raised to the 2nd power x cubed y? And I ask you for the degree of that term. Remember, it's the sum of the exponents of the variables. So this would be 3 plus this 1, which would be 4. You do not take the exponents from the constants. I'm going to stop this little video right here, and we'll come back and work a few problems in the next one. See you in just a bit.